Welcome back from Thanksgiving break. We have 3 more weeks to go until Christmas break. Today we're going to work on translations and reflections on the coordinate plane. Make sure you have your journal open to the transformations on the coordinate plane. We're going to go through 2 of them today. I know you did translations in class, so we're going to take a couple of quick notes and then we're going to move on to reflections. Under the translations tab, looking at our first translation, we're going to graph the translation of the quadrilateral ABCD, and we're going to move it 5 units left and 3 units down. We're going to write the coordinates of the original and the new figure. First of all, I want you to underline our 2 transformations. We're going to translate this 5 units left. Remember, when we move left or right, that changes your x values. Side to side is your x values. And then we're going to move 3 units down. Remember that 3 units down, up or down, changes your y values. So looking at our shape, we're going to start with our coordinates of our first figure. And we're going to write down our coordinates for point A. Point A is at the ordered pair 2, and it's up 1, 2, 3, 4, 5. So this ordered pair is at 2, 5. Point B is at the ordered pair 5, 4. Point C is at the ordered pair 5, negative 1. And point D is at the ordered pair 1, negative 2. Now we're going to move all of these points 5 units left and 3 units down. Put your pencil on point A, and now we're going to move down we're going to move 5 spaces left and 3 units down. I misspoke. So 5 left, 1, 2, 3, 4, 5 to the left, and then go down 1, 2, 3 units. Put a dot here. Now, to label this, we label this A prime. It's an A, and then there's a little apostrophe above it. That means the image of A. So A with a little apostrophe tells us that's where it has transformed. Now, when we move 5 units left, that's like subtracting 5 from our x value. Our x value was 2. If we move to the left, that's subtracting 5. So 2 minus 5, our point is at negative 3 on the x. Our y value went down 3. It was 5, so when we move down 3, that's like subtracting 3. 5 minus 3 is 2. So point A prime, or the image of A, is at negative 3, 2. We're going to do the next one with point B. We're moving 5 units left and 3 units down, so put your pencil on point B. We're going to go 5 spaces to the left, 1, 2, 3, 4, 5, and down 3, 1, 2, 3. Put a dot here. And we're going to label this B prime, or the image of B. The image of B is 5 units left and 3 units down, so we can subtract 5 from our x value. 5 minus 5 would be 0. And then our y value, we're subtracting 3 because we moved down 3. So 4 minus 3 is 1. The point B, or the image of B, is at 0, 1. Our next one, point C, we're going to move 5 units left and 3 units down. It's going to be right here. We're going to label this C prime, so we moved left 5 and down 3. And for our ordered pair, the image of C, or C prime, when we move left 5, that's like subtracting 5 from the x value, so 5 minus 5 is 0. And the y value is like subtracting 3 because we're moving down 3, so negative 1 minus 3 is negative 4. Our ordered pair for our C is 0, negative 4. C prime is 0, negative 4. And D was at 1, negative 2. Put your marker on, or your pencil on 1, negative 2. We're going to go left 5 spaces, 1, 2, 3, 4, 5, and down 3. Put a dot, and we're going to label this the image of D. Our ordered pair for the image of D, well, 1 minus 5 is negative 4 for our x value, and negative 2 minus 3 is negative 5 for our y value. Now we're going to connect these points for our image. Notice for this translation that the orientation stayed the same and the size of the image stayed the same. So it has the same orientation. We have A, B, C, D going clockwise around the shape, and it's the same size that it started. So it does not change size when we have a translation. It's a congruent figure. At the bottom here, I want you to put a little star and write that we subtracted 5 from each x value, and we subtracted 3 from each y value. Now, we could tell that from the beginning here. If we're moving 5 units left, our x value is decreasing. Moving left on our number line is going subtracting, and moving down on our y-axis is subtracting. Notice here in all of the ordered pairs that 2 minus 5 is negative 3. Our y value was 5 for point A, minus 3 is 2. Each of the x values we subtracted 5, and each of the y values we subtracted 3. Alright, the next one we're going to look at, we're going to translate our figure 6 units right and 2 units up. This time we have a triangle that we're going to translate. We're going to write the coordinates of the original and the translated figure. So let's go ahead and write our coordinates for our translated figure. Point A is at the ordered pair -5, -4. Point B is at the ordered pair -2, +2. Point C is at the ordered pair -2, -4. Now, in our information, I want you to underline, we're moving this 6 units right. This is our x-axis. When we move right or left, those are our x values. If we're moving to the right, we're going to be adding 6 to each x value. Write that at the bottom. We're adding 6 to each x value. And then in our next part of our translation, we're moving 2 units up, moving up or down. That's the y-axis. So if we're moving up, we're going to add 2 to each y value. Now, we can find our image without ever having to use our graph. It helps us to confirm that. But we're going to find the image of A, B, and C. If we're moving 6 units right for point A, put your pencil on A and move over 6 units right and then 2 units up. Label that A prime, or the image of A. When we move 6 units right, that's like adding 6, so -5 plus 6 is a +1 on our x value. When we move 2 units up, -4 plus 2 is -2. So our image of A is at +1, -2. Our image for B, put your pencil on B, we're going to move 6 units right and 2 units up and label this B prime, or the image of B. We were at -2. When we add 6 to -2, that takes us to +4 on the x-axis. And we were at +2 when we add 2 to the y value. Because we're moving up 2, we're at 4. So our ordered pair for our image of B is 4, 4. And the last one, point C, put your pencil on point C. We're going to move 6 units to the right and 2 units up. Label that C prime. We were at -2 when we add 6. -2 plus 6 is +4. And then -4 plus 2 is a -2. Notice that in our image, the orientation is the same. The A is the same, is still to the left of point C. Oh, did I move too far? I did. Let me fix my C point. And then point B is still directly above point C. Moved a little too far over on that. And they're each the same distance. So A was still 3 spaces away from C. A prime is 3 spaces away from C prime. So when we translate, it saves the orientation and it saves the size. They are congruent. Translations preserve congruence. They also preserve orientation. That means they're in the same order when we look at them. All right, the next one we're going to look at, if you'll turn the page to our reflection, we're going to graph a reflection. For the first one, example 3, we're going to graph across the x-axis, and we're going to write the coordinates of the original and the new figure. And then for the second example, we're going to graph the coordinates across the y-axis. We'll see what the difference is when we do these two. Now, a reflection is like a mirror image. We're reflecting across the y-axis, so they will tell you which axis you're reflecting across. I want you to go ahead and draw a line across the x-axis to show where we are reflecting. This is our x-axis. Now, they've asked us to write our coordinates for our original and our image, so point A, B, and C. Point A is at -4, 5. Point B is at 4, 4. And point C is at 2, 1. Now, a reflection, like when you see your reflection in the mirror, your reflection is the same distance away from the mirror that you are. They are equally spaced across that line of reflection. So we are going to reflect point A across the y-axis. It is 1, 2, 3, 4, 5 spaces away. So when we are reflected across the y-axis, or the x-axis, I'm sorry, we're going to have it 5 spaces away. Label that A prime. Now, our image of A is now at the ordered pair -4, -5. Take a look at what has changed in those coordinates, and let's see if we see a pattern. Next, we're going to reflect point B. Point B is 4 spaces away from our line of symmetry. So point B will be 4 spaces away when we reflect it across. This is the image of B. This ordered pair for the image of B is at +4, -4. And our last one, point C, is only 1 space away from our reflection. So we're going to reflect it 1 space away on the other side and label this C prime. Then we're going to connect all of these points. There we go. Now, for this, we have our triangle, and point C was at the image of point C is now at the point 2, -1. Now, looking at this reflection, we're going to look at our ordered pairs and see what we notice. We had -4, 5 for the original point A. Its image was at -4, -5. Point B was at 4, 4. The image was at 4, -4. And point C was at 2, 1. The image was at 2, -1. So, put a little star here. When we reflect across the x-axis, what changes in your coordinates? You'll notice from these ordered pairs that when we reflect across the x-axis, when reflecting across the x-axis, the y value changes sign. So when you reflect across the x-axis, that is like multiplying the y value by -1. So you are writing, when you reflect across the x-axis, you multiply the y value by -1. If we look at this, we had 5. Our 5 changed to -5. Then we had 4 for our y value in point B. It changed to -4. Then we had 1. It changed to -1. So the sign of the y value changes when we reflect across the x-axis. Reflections saved congruence, so these two triangles are congruent, but it did not save the orientation. In our reflection, it has flipped across that x-axis, and the C has changed places. C is on top of the triangle when our reflection instead of on the bottom, so it does not save orientation. It does save the congruence, though. All right, our last example for today, we're going to look at example 4. In example 4, we are reflecting over the y-axis. I want you to think for a minute what might happen to the ordered pairs if we reflect across the y-axis. Remember, reflecting across the x-axis changed the sign of our y-coordinates. Now, writing down our ordered pairs, we have a quadrilateral Our quadrilateral is A, B, C, and D. And these points are at, let me find the right tool. Our points are at -6, +4 for point A. Point B is at -3, 4. Point C is at -1, -2. And point D is at -4, -2. We're going to find the image for each of these, the image of A, B, C, and D. We're going to find their ordered pairs. Now, draw a line on your y-axis. The y-axis goes up and down, so this is our line of symmetry that we're reflecting across. Starting with point A is 1, 2, 3, 4, 5, 6 spaces to the left, so when we reflect it, it's going to be 6 spaces to the right. This is the image of A. Point B is 3 spaces away from our line of reflection, so it's going to be 3 spaces on the other side. Notice that point A and B are still the same distance apart. They're still 3 spaces apart. Point C was 1 space away, so when we find the image of point C, it's 1 space away on the right-hand side of our line of symmetry, and point D was 4 spaces away, so it's going to move over 4 spaces on the opposite side. We're going to connect our quadrilateral. It's the same size as the original, but it has flipped the direction. So our size stayed the same, but the orientation changed. Now, taking a look at these ordered pairs, point A this time is at 6, 4, or the image of point A is at 6, 4. The image of point B is at 3, 4. The image of point C is at 1, -2. And the image of point D is at 4, -2. Now, taking a look at all of these ordered pairs, what do you see changed? All of the Y's stayed the same, but this time all of the X's changed signs. So at the bottom, we're going to write, when you reflect across the Y-axis, the X values change signs. Reflecting across the Y-axis, we multiply the X values by -1. Remember, multiplying by -1 just changes the sign of what you multiply. So we multiply, let's see if I can get this eraser working. We're going to multiply the X values by -1. Okay, make sure you have these ready for tomorrow. We're going to work on reflections for a couple of days as well as translations some more, and then we're going to move on to rotations and dilations on the coordinate plane.